So in this one, we are going to be using signals to actually do something after this model is saved. So there's all sorts of signals that allow us to work with our models in a different way. And what signals do is it's just like it sounds. If something happens to the model, a signal is sent, and you can do stuff with that instance of that model. So let's just take an example so you can kind of see what I mean. First off, we're going to define a receiver function. So what a receiver function means is when a signal is sent, the receiver function handles what that signal is sending. So we're going to call this update user answer score. And it takes in a few arguments, but the ones that we're concerned with is sender, instance, created, and then we'll just add args and keyword arguments. So any other arguments or keyword arguments would come through here, just in case. So sender is going to be the model that's being sent. Instance is the actual instance of the model class. Created is a Boolean value, so whether or not it's created. So you can also print all these things out. So sender, print instance, and print created. So this is the actual receiver function itself. So in this case, we have an instance. So our instance means that we can actually go through here and get the importance level and also their points. So the reason I put -1 as the default is because our score importance never hits -1. It's never going to be -1 after we set it for the very first time. So this is all that we're doing here is we're going to be able to set it for the very first time. And our default of being also -1 would imply that it was never set in the first place, so this question has to be answered in some other form or fashion. But it's just a way to kind of separate the data and not confuse us at any point, because if we put the default at 0 or one of these other ones, then the user might have made a mistake, or we as a developer made a mistake somewhere along the lines on how we assign that value. So instead, we just assign it to something drastically different than our score importance. Since we're talking about the points and the values, all of these numbers are arbitrary. We just kind of picked whatever we wanted to kind of go here. And this is going to be completely up to you. You could also add other importance levels if you want. I went with 4 because I think 4 is a good number. Mandatory, meaning it absolutely has to be there. So that's going to be a lot higher than all the other ones. Very important being that it's very important, but it's not quite a mandatory. It's 200. And then somewhat important is just, a sixth of the other ones or the other mandatory. That's okay. And then not important is 0, right? So that one kind of makes sense. These numbers is something you could play around with. And again, if you added other importance levels here, maybe a couple more, you might actually want to have that. But if you wanted 1 through 10, you could do that as well. So there's all sorts of things that you could do with this. But anyways, so now that we've got this idea explained, let's see how we would come through here. So an instance is being passed into this function. So this function's actually going to be ran. So that means we can do some checks here. So the first one, we'll see if the instance dot myPoints is equal to -1. So if the points are equal to -1, then we want to actually update the value for these points. So this is going to change what this value is specifically. So we'll do, this means that the points haven't been assigned yet. So we'll go ahead and run the importance level on here. So we'll just say, first off, get the points. So my points, so it's going to be my new points is equal to, we're going to grab the instance importance level and pass it through the function of score importance. So here we'll just do instance dot, and then this is going to be my answer importance. So my answer importance, just like up here in this field. So this is going to go through this, except we need to return points in this function. So now it will actually return those points, and this is now an integer that would be related to those points. So then we can actually add in here that instance dot myPoints is now equal to my points, which is this right here. And then we can save that instance.save. All right. And then also, we're going to do another if statement. If instance.theirPoints is equal to -1, then we will say the same sort of thing, but instead of it being score importance of my answer importance, we'll do their importance, or their answer importance, and again, their points all the way through. And there we go. So that is actually the signal receiver that will actually run through this. The last thing we would need to do is actually import a post-save signal. So basically, after the signal has, or after the model has been saved to the database, a signal can be sent for the post-save of it. So I just need to do some imports here, and it's from django.db.models.signals import post save. And then down underneath the model itself and underneath the receiver function, we're going to do postsave.connect, and the receiver is the receiver function, right? So it's giving us this completion here, but the receiver function is this, and then the sender is the user answer class. So whenever this is saved, so this is all it's doing, is whenever it's saved, it's going to send through to the signal. So let's go back into our admin, or let's check out our admin. Or actually, we don't need to check out our admin. We can just save here. So is this true? We hit save and continue. Nothing seems to change. So let's go into our admin and take a look at these scores. So user answers. And that's not the one. Here, that's not the one either. And it looks like it didn't save. So let's take a look at our signal itself. And our signal did come through. And here's the problem right here, is it's not a string of -1, it actually is the integer of -1. So let's try that one more time. We'll have true in here, I'll just hit save and continue. And notice it sets the points for us. So that's what that signal did just there. So this is good, this is cool that we can actually do this, but there is one problem. And that is if we go and try and answer this question again. So let's go into that local, and we'll go into question 2, I believe it is. Yep. If I try to answer it again and just say somewhat important, and then true, save and continue, the scores don't update. So this gives us the opportunity to take a look at signals in general, or other signals that we might want to use. Now in this case, we did a post-save signal, but there's another one called a pre-save signal. So we can see over here different types of model signals that we can use. So this is actually really useful for us. There's pre-delete, post-delete. Let's take a look at post-save first. And we see here that this is the post-save signal. Here are the arguments that are being sent. Sender instance created, raw, using, update fields. So you can read through and kind of see these things. But we also have a pre-save signal. So this is before it's actually saved. It actually updates stuff before it's actually saved. So let's actually use this one this time. And we'll go back in here. And I'm going to just add the pre-save to our import at the very top of our model. And we'll scroll down to the bottom. So something to note here is that you can also do if created. So a very nice one here is if the model is created, then we can set it right off the bat. That is one way to set this data. But again, we want to use the pre-save signal this time. So I'm going to go ahead and just comment this stuff out. I'll keep it in the code just so you can see it. And then I'm going to paste all of this stuff back in. And now instead of post-save, I'm going to use pre-save. And we do want to take a look at the pre-save arguments that are being passed. We only have these 5. Notice created is not in there, so we have to get rid of created. And I'm also going to get rid of these print statements. And then lastly, we don't actually need to run the instance save method here. We can go ahead and cut this. So I'm going to cut it out and hit post-save here. Or pre-save, excuse me. So the reason we don't have to run it is because the save method is ran right after this. So I'm going to go ahead and cut that, paste in here, and there we go. So now this will actually update the score every single time it's saved, or right before it's saved, it's actually updated here. So let's actually, before I do pre-save, I'm going to also do post-save on this one and see what happens. So let's go back into our user answer. Of course, I can actually make the changes here. I'm going to do somewhat important and hit save and continue. Notice it doesn't change. Not important, save and continue, does not change. If I go to pre-save and just hit save and continue, it changes those points. Now, the reason for this is because the post-save, or the save function, is going to run after the pre-save signal itself. So when we did this post-save, we have to actually run the method of save on the instance to actually save it. That's where we can come into a lot of issues, because if I try to run basically all of this, so let me just copy this and put it back into this post save. Let me comment. I'm going to comment everything out here. If I try to run this and then instance.save, what's happening here is once the model is saved, it connects to this function here, this receiver function, and then it's going to save it again, and so it's going to connect again. And it's just you're going to go in this infinite loop, and it's going to run an error. So that's something you definitely don't want to do. In this method, don't save like this. Where here, we did a statement of whether or not the points were assigned to a certain value. Really, we're just checking to see what that certain value is so we can actually run this post save function. But both of these signals are very, very useful. And like most things in programming, this is not the only way that you can actually connect these receiver functions to a signal. So to actually do it, there's another one, a decorator called receiver. And looking in the Django documentation, this is the receiver itself. So we can actually come in here and go to import the decorator itself. So dispatch receiver. And down here, on a receiver function, we would say at receiver, and then the signal itself, so the signal that's coming through is pre-save, and then the sender is going to be user answer. So these two, this right here and this right here, do the exact same thing. So if I save that, then now I can go back in here. Let's do it one more time. Do very important, hit save and continue. And we have a little bit of a maximum recursion depth problem. So this error right here is because of this post-save stuff. So I'm going to, again, comment that out, get rid of it. I'll refresh one more time and save. Notice very important changed. So mandatory, hit save and continue, it changed as well. So this is another way to actually write this, a way to connect to the signal itself. So this is declaring this as a receiver function for the pre-save signal, which is really cool, and also for the sender of user answer. So that's how we update those scores, and this is really cool. So now we have a few different ways on how to actually do it, but more importantly, now that we have scores, we can start to actually use those scores to build some sort of matching algorithm, and that's something we'll actually start doing in the next one. If you have any questions on these signals, definitely let us know. Also, check out the documentation. There are all kinds of signals. And yes, you can define your own custom signals as well. You don't have to go off of just the Django ones. But it's not something we'll cover this time because it's not necessarily needed for this project. But there are all sorts of things that are really cool, like a pre-delete one. If you need to delete other data somewhere because of a model being deleted, this is how you would do it. Post-delete, if you needed to do it after that instance is deleted, that's good. You can do that as well. But notice the post-delete, the object is no longer in the database, whereas the pre-delete, the object will still be in the database because it hasn't been deleted yet, right? And then many-to-many changed. This has to do with what we talked about before, where if we had our questions being a many-to-many field or answers being a many-to-many field, this is a signal that recognizes whether or not it has been changed, which is really cool. And it has all sorts of arguments here, which is something that you could play around with too. All right, so if you have any questions on this, let us know. Otherwise, let's keep going.